All right, let's learn how to sketch basic rational functions. So we're actually going to sketch this using the asymptotes, domain, and range. So what I have on the side here is the parent function and all the details for the parent function. So a rational function, the parent function is 1 over x. The x value cannot be 0. Because of that, the range, you will never get 0 as a y value. Your domain translates into the vertical asymptote, because if x can't be 0, your asymptote shows you where it cannot touch, and your range translates into your horizontal asymptote. So when we sketch functions, really the only thing you need to know are translations, how these things move. So this function, y equals 1 over x minus 3 and then plus 1. This shows two different translations. First, your rational function, your parent function is 1 over x. So x is in your denominator, which means anything that happens inside your denominator, in this case the minus 3, is a horizontal shift. So we're going to shift horizontally along the x-axis, which means it's going to affect our domain and it's going to affect our vertical asymptote. All these things are connected. If you have x minus 3, it means it shifts not to the left but to the right. This is one of those tricky ones that you want to make sure you practice. So it shifts to the right 3 units. That means your domain is not when x is not equal to 0, it shifts. So your domain is going to be when x is not going to be able to be 3. If you plug 3 into this denominator, 3 minus 3 is 0, which we cannot have. If we shift that 3, then our vertical asymptote is also going to shift. And if it's originally 0 and we shift 3, then our vertical asymptote is going to be x equals 3. So we have a graph with an x and y axis, and we already know that x cannot equal 3. So that's our vertical asymptote. We cannot touch that graph, or that part of the graph. So the other part we're given here is this plus 1 on the outside. So same thing, anything that happens outside of the fraction is a vertical shift. So because that says plus 1 away from the function, that is going to move up 1 unit. Now that affects your vertical, which means it affects your y. So your range is going to be affected. Instead of y not being able to equal 1, now your y is not going to be able to equal 1, not 0, because it's shifting up. So your horizontal asymptote, again, y couldn't be 0, or y equals 0 is your normal asymptote. Because this shifts up, that shifts up to y equals 1. So now we have our horizontal asymptote where y is equal to 1. And now you can make points and get the actual points, but your parent function for rationals look like this. So if we shift this up and right, now instead of not touching the x and y axis, you just can't touch those. So that would be the sketch of your graph after moving and shifting. So we'll do 2 more examples just so you get an idea of what's happening. So this is another rational function. So we know our parent function is going to look like this. And all of these aspects are going to change based on the shifts that we see within our equation. So we have y equals -8 over x plus 3 minus 2. So what I would do is I would actually take the 8 out of that fraction and write 1 over x plus 3 and then the minus 2 outside. Now the reason I want to do that is because our rational function, our parent function, has a numerator of 1. So that -8 tells us something that's important that's going to come later. First, we have x plus 3 in our denominator. That is a horizontal shift. Now if that says x plus 3, then we're going to move to the left 3 units. If we're moving left, our domain is going to shift. Instead of 0, x cannot equal -3. That also affects our vertical asymptote. Instead of x equals 0, x is going to equal -3. So I already have my vertical asymptote. So we can draw that. We have our y-axis, x-axis, and -3 is not going to work. So I have my asymptote. I have a -2 out here. That is a vertical shift. That is outside of the fraction that is being added or subtracted. So because that's minus, we're going to move this down 2 units. So we're moving down. Your range is not at 0 anymore. Your y value is not able to be -2 because it's moving down. Your horizontal asymptote is not when y is 0. Now it's when y is -2. So I can draw that horizontal asymptote, y equals -2. So we have our parent function. That's our graph. We just have to copy and paste it into this section, except for the fact that we have this -8. When you multiply a function by a negative, that is a reflection. So that negative is being multiplied by the fraction. So it's a reflection over the x-axis. It's actually a vertical reflection. It's outside of the fraction. That's why it's important to understand that. So instead of your graph being this red in the corner, it's actually going to flip. And your graph's going to look like that because of the reflection. So our graph is going to be in the lower right section and the upper left section. And that would be a general sketch of the graph. You can pick numbers and plug them in. You just cannot plug in -3. You could plug in any number around there and kind of figure out where that goes. So let's do one more. I know this video is a little long. So in this case, you're actually given the equation and you're going to write it based on the shifts. So you have an equation, y equals 4 over x. So I'm going to rewrite this, and I'm actually going to rewrite it as y equals 4 times 1 over x. This way I can see my rational function 1 over x. So this already, that 4 is telling us that it's a vertical stretch of 4. We're not reflecting anything. We're just going to have larger y values. So our asymptote, x has an asymptote of -5. So we can sketch this first if we wanted to. At -5, it's over here, we have one asymptote, and when y is 7, we have another asymptote. So let's do the x first. That x is a horizontal shift, which means your domain and your vertical asymptote get affected. Now, if your vertical asymptote is -5, it means that 0 is shifting left 5 units. Your domain is going to be x cannot equal -5. Well, if x cannot equal -5, then your denominator has to say x plus 5, because the -5 plus the 5 is going to give you 0. So again, x cannot be -5, so your denominator should say x plus 5, because that would give you 0, which is not allowed. The other asymptote is y is 7. So this tells us that this graph has been shifted up 7 units. That's a vertical shift. So your range is also going to shift up 7 units. So we would write our equation like this with the plus 7. So our equation now with these shifts would be 4 times 1 over x plus 5 plus 7. Or it could be written as 4 over, which is probably how you're going to see it, x plus 5 plus 7. And we have our asymptotes. So if you wanted to graph it, if you're like, hey, this is exciting, let's graph it, then our graph would go in the bottom right or bottom left and upper right hand corner of those asymptotes. So that's how you graph using reflections, vertical, horizontal, reflections, the whole thing. But this should hopefully help you in graphing any kind of rational function.